students, welcome to the lecture number 8 on hydrocarbon chapter. In this lecture we are going to discuss some of the chemical properties that we have not discussed in the previous lecture, that is in the lecture number 7, the properties of the alkyne. So heading of today's lecture is properties of alkyne part 2. Before going to discuss the relevant chemical reaction as per your syllabus in this class 11 syllabus, organic chemistry syllabus, let us have some recap what we have learned in previous 7 lectures. In the lecture number 1, we have discussed about the preparation of the alkene. In the lecture number 2, we have discussed about the physical and chemical properties of the alkene. In the lecture number 3, we have discussed about another very important hydrocarbons, that is alkene. And in that lecture, we have discussed about its preparation of the alkene. In lecture number 4 and 5, we have concentrated on the physical and chemical properties of the alkene. In the lecture number 6, we have again started the new hydrocarbon, the basic very important hydrocarbon, that is alkyne. And in that lecture, we have discussed about the preparation of the alkyne, its nomenclature and its isomers. In the lecture number 7, we have discussed about the physical properties of the alkyne and some chemical reactions that we have discussed. That is, we have discussed basically the acid property in the chemical reactions. That is the acid property we have discussed. Then we have discussed the addition reaction as being undergo by the alkyne, that is the addition of dihydrogen, addition of halogens. Now in this lecture we are going to discuss the remaining chemical properties, chemical reactions that as undergo by the alkyne. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. So first reaction that is being we are going to discuss, that is the addition of halogen acid. In this lecture, we are going to discuss first the addition of hydrogen halide. Hydrogen halides or halogen acid, whatever you may call it. This addition of the hydrogen halides or halogen acid is being done as per the Markov-Nikov rules that we have understand in our previous lectures, and is a very basic rule when we are going to add these acids or this type of molecules which is having the two parts, that is one that is it will create a electrophile and another is the negative part. And for the unsymmetric alkane, that is a very much decisive one to understand the which type of product is going to be produced out of that. So addition of halogen halides, we are taking the HBr. First we are taking the symmetric alkyne, that is ethyne. This is ethyne. And we are taking the halogen acid, is HBr, hydrobromic acid. So here in this symmetric alkene, there is this alkyne or alkene. In this case, this is alkyne. In the ethyne, when this is added, what is going to happen? One part, that is HBr, will first create the electrophile and it will going to produce a carbocation. This is a carbocation, and this negative part, that is here H plus ion, is added, and this negative part, that is Br minus ion, will be added to this slightly positively charged carbon atom, and it is going to produce this. Very simple thing to understand. So you will observe the preparation of bromoethane. This is bromoethane. Bromoethene. Still it is an unsaturated one, so it has the capability of taking up another molecules. So in the alkene, what we understand, one molecules will be added. In the alkyne, you will see that two molecules will be added. This is one molecule is added here. This is one molecule is added here, and another molecule will be added in this here. And in the same fashion, that what we have discussed here, that there will be a formation of a carbocation, and this positive point, we will see the negative part of this molecule will be added. So it is going to create this product. What is this? This is 1,1-dibromo, because two molecules of bromine is attached, dibromo, 1,1-dibromoethane. Now this is a saturated hydrocarbon, ethane, and this is also called, its common name also, gem dihalide. Gem dihalides. This is also called. There is two types. When there is a more than one halogen has been attached to this alkane, that is going to produce these halides. When there is a two halogen atom, and there is a possibility that both these halogen atom will be attached to the same carbon atom, at that time it will say the gem dihalide. When this halogen atom will attach to the different carbon atoms, adjacent carbon atoms, it will call the vicinal halides. That we have studied in our previous lectures when we are studying the preparation of the alkyne. From this vicinal dihalide with the alcoholic KOH and subsequent with the sodamide, what we have understand, that there is a formation of the acetyl. So this is the reaction where we observe the addition of halogenide halides, and it is going to produce the 1,1-dibromoethane, and this is also called gem dihalides. Now we are taking this is propyl, and again we are taking HBr, addition of HBr. In a similar fashion, we will find that there is a formation of the carbocation, and this that point the negative part will be added. So here you can see, first this will form, bromine will attach here, and hydrogen will attach here. When hydrogen will attach, it will first create a positive charge in this carbon atom, and the bromine minus ion will be added there. So you will understand, to form, this is 2-bromopropyl, 2-bromopropene, right? Then another molecule HBr will be still added to this propane and it is going to produce this. That is 2, 2. There is second number position. You will see this bromine atoms have been attached to this carbon. It is 2,2 dibromoethane. 2,2 dibromopropane. Okay, so you understand the addition of halogen halides. Now, second that we are going to discuss the addition of H2O. Addition of H2O. H2O normally is not going to be added in normal condition because we know that ethane is not soluble, or you can say miscible in water. Not only ethane, alkene also. But if you create the proper conditions, at that time you can observe that it will be dissolved. But here difference is that in the previous addition reaction, what we have observed that there is the addition of the two molecules. Here we will observe only one molecule will add and it will going to produce the carbonyl compound. So this reaction is like this. You have taken ethane and this reaction condition is like this, that you have to take mercuric sulfate in presence of sulfuric acid and you have to put the temperature you have to maintain, that is 333 Kelvin. At that time what is going to happen, it is also going to follow the Markovnikov rules. So at that time you can find that in the one of the carbon atom hydrogen will be there and another carbon atom OH will be there. The next reaction is not stopped here. There is a further isomerization process is there. Isomerization. In this process, what is going to happen? This hydrogen atom will be shifted here. So this double bond has been shifted in this position. So it is going to produce this CH3COH. So what is this? This is the carbonyl group has been produced. So this is this material is ethanol. This is ethanol. Now if it is the propane, CH3C1CH, then what is going to happen? Let us see. The reaction condition will be same as before. So here also you can see there will be addition of this here CH3 OH will be added here as per Markovnikov rule and CH hydrogen will be here. Okay. Now there is again isomerization process is there. The rearrangement process is that the hydrogen will be shifted here and it is going to produce here this carbonyl group and it is this. So what is this? This is propan 1. This is propan 1 or with the dimethyl ketone. We can also say propan 1. Okay. So this is the addition of H2, and this is very important. Different type of questions come that we have to give this different type of alkynes will be given, and you have to say which type of product will be there. So from this knowledge you can able to easily say. Now we are going to discuss another very important reaction, that is the reaction with the Grignard reagent. Here that is going to be reaction with Grignard reagent. Reaction with Grignard reagent. Suppose you have taken this C=CH profile, and you are taking this Grignard reagent CH3MgBr. CH3MgBr is a Grignard reagent, so it will going to produce CH3 C111 CMgBr. This is also a Grignard reagent, we will say, and there is a evaluation of the methane. Question normally comes, you have been given this reaction and be told which gas is going to liberated from this. At that time, this will be the right answer. In this regard, let us have one question that will give you a lot of insight into this reaction. That is, the question is this. You have to say which of the first A is there, what will B is there. The option is giving here, multiple option is giving here. That is, number one option is this, chlorine. Number two, number three, so this four option is given to you, and you have to say which is B here. You have to say the B. If you understand this reaction, you can able to, with the fraction of second, you can able to solve it. Try yourself and say what will be the product. So first one that we see, this Mg will react with this Br, so it is going to produce this ClMgBr. Okay, now you can see from this reaction and from this reaction what is going to happen. B will be basically this MgBr will be replaced by this D. So this will be the ClT. where and there is a production of another production, that triple bond CMgBr. This is the Grignard reagent is produced, and this is the product, you can see. So their answer will be 1 is the correct answer. So this type of questions is normally comes in your exam, that you have to solve with a very few seconds. So you have to understand it first properly, then you can able to see this. We are going to discuss the fourth number of reaction, that is the polymerization. In this reaction, we will the polymerization reaction also being carried out by the alkene also. Polymerization reaction is the reaction where you can find a very simple molecule will be added up with a large number of species, and it is going to produce a very large molecules, and this is called the polymers, and it is the reaction is called the polymerization reaction. In the same way, in the alkyne also is going to observe the undergo these polymerization reactions. Here also we can understand, we see that two types of polymerization reaction is occur, that is one is linear polymerization. In the linear polymerization, that is the molecules will be add up linearly and it will produce a very large chain. Linear polymerization, linear polymer you can see. In this case, the repeated unit will be like this. This will be the repeated unit, and that depends on how much we are going to get from this polymerization reaction. That is depends on the product which is going to produce. So this linear polymerization, and it is going to produce the polyacetylene. Polyacetylene. This is going to produce the polyacetylene, and this has a very unique application because this polymer is going to conduct the electricity because of the presence of these pi electrons. So under the pressure condition, you can able to use it as a electrode also. In the electrode, normally you use the metals which you find that is a very heavier, but when you are using this very thin sheet of the polyacetylene, it will going to make this battery is very lightweight battery. So nowadays this type of polymer is used as a electrode. So this is a good applications. And another type of polymerization that is also very important thing, this is called the cyclic polymerization. Cyclic polymerization, it is also very important application because you can see the alkyne is a very important ingredient for many others polymers, many others organic compounds. Like you can produce the alkene, you can produce the alkane, and other types of compound you can observe. And in this way, by cyclic polymerization, you can convert the aliphatic hydrocarbon, that is straight chain hydrocarbon, to the cyclic hydrocarbon, that is benzene. And you can see this reaction you can see here 3 molecules of the acetylene, when it is being passed through a red hot iron tube, and it is having the temperature around 873 Kelvin, what is going to happen? That you can easily understand that this will go into this, and this will go to this, and it is going to produce the benzene, the aromatic hydrocarbon. So you can understand this CH double one, CH single bond, because we know in the benzene there is alternate single bond, double bond, single bond, double bond. So you can write this in this way. So you can see this benzene itself is a very useful ingredient for many other hydrocarbons, salicylic acid, phenols, all the things have been produced from this benzene, and benzene has been produced from this acetylene. So this is a very, very important reaction in the industry. Lot of ingredients has been, lot of organic compounds have been produced out of that. Now question arises, sometime this question is normally given, if we have taken this propyne, then what will be the product? And it is under 400 Kelvin. What product will we get? We will get this we will get the derivative of the benzene. This is symmetric trimethyl benzene. This is symmetric trimethyl benzene. So this is a very, very important reaction, polymerization reaction. Here you can see the two types of polymerization, that is a linear polymerization and the cyclic polymerization. So that is all for today's lecture. In this lecture we have discussed the remaining chemical reaction that we have not discussed in the previous lecture. In the lecture number 7 we have covered, in the lecture number 8 we have basically concentrated and discussed first the addition of halogen acids, then we have discussed the addition of H2, then we have discussed polymerization. So that is all for today's lecture. If you like this lecture, you can share to your friends. Thank you very much for watching, and we will come with another topic in this hydrocarbon chapter in the next lectures. Thank you very much for watching.